Here's a competition problem. How many strings of 4 opening and 4 closing parentheses have the property that every prefix, every left to right start of the string, contains at least as many opening parentheses as closing ones? That condition sounds bureaucratic, so it's worth translating. It's really about balance as you read. At no point are you allowed to close a parenthesis you never opened. So a string like this one is fine, and this one breaks the rule at the third symbol. That closing parenthesis has nothing to close. When a counting problem has a side condition I don't fully understand yet, I like to drop the condition first and see what's left. Without the prefix rule, I'm just choosing which 4 of the 8 positions hold the opening parentheses. 8 choose 4. 70. So the answer lives somewhere below 70, and everything now depends on counting the strings that break the rule. And here's where it gets interesting. The direct route is to count the bad strings, split them up by where the first violation happens. It turns into cases, and the cases have cases. The bad strings don't have an obvious shape, at least not as strings. Whenever a rule is about a running total, I draw the running total. Read the string left to right. Opening parentheses, step up. Closing parentheses, step down. 4 of each, so every path ends back at height 0. And the prefix rule becomes something you can see. The path is never allowed below 0. A bad string is a path that touches -1. Suddenly, the bad ones do have a shape. Now the idea, and the first time I saw it, it felt like it shouldn't be allowed. Take any bad path and find the first moment it touches -1. From that moment on, flip it. Mirror the rest of the path across the line y equals -1. Every remaining up becomes a down, every down becomes an up. The original path ends at 0. The mirrored one ends at -2. Count its steps, 3 ups, 5 downs. Every bad path turns into a 3 up, 5 down path. And it works backwards. A path with 3 ups and 5 downs has to cross -1 somewhere. Flip it back at that first crossing, and you recover exactly the bad path you started from. 1 for 1 in both directions. That's something I find quietly beautiful about counting. Sometimes you never count the hard things at all. You match them, 1 for 1, with things you already know how to count, and then the 2 counts have to be equal. Paths with 3 ups and 5 downs, choose where the ups go. 8 choose 3, 56. So, 70 arrangements in total, and 56 of them break the rule. 14. So exactly 1 arrangement in 5 survives. And that 14 isn't an accident. It's the 4th Catalan number, the sequence that shows up whenever things have to open before they close. If you want to try the flip yourself, do 3 pairs of parentheses. 20 arrangements in total. Count the bad ones with the same reflection. 5 when you're ready to check. See you in the next problem.